Evening, folks. Brian here, Geomagnetic Earth Watch on Saturday, January 20, 2023. 2024 on our planet. Hope you're all well. I'm not on our planet. I'm somewhere else, obviously, because planet Earth wasn't letting me have my nap today. So anyway, I initially wanted to do a short video explaining what an antipode earthquake is, but I'm going to mix it up a little bit. So when I said a global seismic event, a sudden increase in both deep earthquakes globally and magnitude 6+ earthquakes globally, and actually a lot more than that. There were quite a few 5+ earthquakes, 5.5s, 5.7s, etc. So that is what I meant by a global seismic event increase. One after another, and another, and another, and another. Some in areas where we do expect, others in areas where we don't have deep earthquakes. So the one in Western Brazil, we normally don't have deep earthquakes there. However, across the border in Peru is common for deep earthquakes. Now, they had to change that around a whole bunch of times. I believe they settled on 6.7 at whatever the depth was, 600 kilometers deep. So let me explain to you the composition of the Earth's layers. I'm only going to concentrate on two, and that is the mantle. So the lower mantle and then the upper mantle. And in between, we have something called the mantle transition zone, where our deep earthquakes occur. Our mantle transition zone is between 410 and 660 kilometers deep. That's where most of our deep earthquakes occur. Occasionally, though, there's been a few at 750 kilometers deep. This just suggests that maybe there's some ongoing changes going on within the structures of our planet. So today it's been like there's been an envelope of pressure around the globe, or rather an upwelling internal pressure from the outer core, what we call outer core expansion, because of the outside electromagnetic influence, the pull on our outer core. Maybe from cell. So antipode earthquakes. So this was done, scientists at Oregon State University looked at 44 years worth of earthquakes, over 5,000 earthquakes, and they found evidence that seismic waves from an earthquake of 6.5 and larger can travel through the center of the Earth, coming out on the other side and triggering earthquakes of magnitude 5 or larger. Otherwise, anything above magnitude 6.5 will lose between a 1 and a 1.5 magnitude by the time it comes out at the opposite side of the planet, the antipode, not pinpoint, but within 30 degrees. Because that energy, that seismic wave, wants to find the point of least resistance. And I'll give you a few examples. Quite often earthquakes, large earthquakes in the Philippines. So the pinpoint antipode is Brazil, not today's deep earthquake. The pinpoint antipode is northeast Brazil. However, that seismic wave doesn't go to that point. It wants to find the point of least resistance, and almost every single time the antipode will fall in the mid-Atlantic ridge, in the middle of the ocean, the Atlantic ridge. Argentina is a very common area for deep earthquakes. The antipode is between the edge of China and Taiwan. Another example, the destructive Turkey earthquakes earlier on, 8.1 or 2, two of them. There were two major earthquakes in Turkey. The Kermadec Islands, north of New Zealand, was the antipode. It was hit with a 7.3. Therefore, earthquakes can be predictable based on antipode response. And after you watch this enough, you know where it's going to be. Another very interesting one today, the Southwest Indian Ridge, south of Madagascar. There was 2 earthquakes, up to a 6.3. The last time there was a substantial earthquake there, the antipode was precisely offshore California, San Diego, well south of the Mendocino Ridge, not on the Cascadia subduction zone. That was a hit, and they quickly got rid of that earthquake. Fortunately, I still have a screenshot of it. So, yet another earthquake, south of Madagascar, antipode, off the coast of California. We shall see. So the problem with today's multiple earthquakes, including deep earthquakes, could there be a deflection of the seismic waves as it's traveling through the earth, and then another one comes up and knocks it off course? It's possible. So with a deep earthquake in Brazil, and the antipode would be, oh gosh, the antipode would be South China Sea, Borneo Island region. However, we had other deep earthquakes. So once again, seismic wave travels through the center of the earth, right? But if we have multiple waves coming in, it might cancel it out. It might just deflect it away, come out somewhere else now. That's my own theory. That's just what I think what could happen. So the way I see it, and I've seen this happen so many times, when all of a sudden throughout the planet we have all this great increase, and usually it's in the same magnitude range, approximately, and today is between 6 and 6.5 or so globally. This tells me there's an equal pressure being expanded, coming up from the outer core, pushing up all around the planet. So we can also expect perhaps some more volcanic eruptions, Iceland maybe. We can also expect, what can we expect? Anybody in the classroom? Arnold, are you there anywhere, Arnold? Could we expect some more heat indications? I wonder. It's okay. I welcome anybody's opinion. I don't know it all. Sometimes you people teach me some stuff. Anyway. It's one thing I have noticed, that according to NOAA, there's a prolonged acceleration of the solar winds. Their modeling says up to 600 kilometers per second, and I just checked, and it's over 400. I don't know where that came from. I don't know where it came from. Sal, is that you up there? You getting closer? Let me have my naps. So, the sun's getting agitated. Those flares are building up, man. Those two regions, okay, they're getting stronger as they're coming directly into Earth facing. It's not going to be a side swipe with the pillow. It's going to be the frying pan right in the nose if it continues. We already have one inbound from that long duration flare. And again, a long duration flare will have more of an impact than a higher short duration flare. We don't have the timing yet. I'll tell you when I get it. That's it for now. Antipode earthquakes. Anything with this was based on a study quite a few years ago now. Obviously, there's been a lot of changes going on within our planet. So parameters could change. So again, large enough earthquake can send the energy traveling through the center of the earth, and it'll come out on the other side within 30 degrees. It'll find the point of least resistance. So very large earthquakes. You can predict or forecast an antipode response, large response. So I think that's it for now. Kids, Arnold, thank you for coming to class today. I'll speak to you later. I'll be back.